pambozi ndimtima umo. Tiende pambozi ndimtima umo. Tiende pambozi ndimtima umo. Tiende pambozi ndimtima umo.
Hello everybody, welcome to MTN Teleschool. My name is Samanenga, a teacher of mathematics. Once again, I'm here with you to help you prepare for your final exams in mathematics. And this afternoon we are going to revise a few questions from the 2018 GC Paper 1 and see how best we can also go about helping you to prepare for your final exams. Right, so before we continue, please remember to tag your friends and your family so that they can also join in this revision exercise to prepare you for the forthcoming exam that are just around the corner. You don't need to stress when it comes to mathematics. You just have to be there and pass with flying colors. Right, so now let's go ahead with today's work. We are going to look at question number 2. In the 2018 July General Certificate of Education paper. So the question number 2 states, evaluate 27 raised to power 2 over 3. We want to start on a very slow note, and then we'll build up from there and see how best we can build up the concepts. Now, when you look at the question that has been given, the question is purely based on indices. And I can give an example to say, given that, for example, 2 to the power 3, this 2 is a base, and the 3 is called a power, an exponent, or an index. And the plural for index is indices. And this question we are trying to revise right now is based on indices. And so there are some basic rules of indices that can help you answer any question on indices. So let us try to look at some of the basic rules that we can look at this afternoon. The first one is, for example, given a to the power m times a to the power n equals a to the power m plus n. What does that mean? It means that when you are multiplying powers of the same base, you add the indices. Whenever you are multiplying powers of the same base, you add the indices. And so this is one of the first rule that we can look at, the basic rule that we can look at. A raised to power m times a to the power n is equal to a, then m plus n. And some of you may be wondering, what is this? Because I'm just writing letters and then it's not really making sense. Okay, for example, let's say we've been given 3 raised to power 4 multiplied by 3 raised to power 2. We can see that the bases are the same here. And once we establish that the bases are the same, then it means we are going to add the indices. So this means the rule which is above there, we are going to write 3 and then 4 plus 2, which gives us 4 plus 2 power 6. That is what the first rule means. You can also find the same because 3 to the power 4 or 3 exponent 4 is the same as multiplying 3 by itself 4 times, like this, then times 3 raised to power 2 is the same as multiplying 3 twice. So we're going to have 3 times 3. And then when you count the number of 3's we have 1, 2, 3, 4, 5, 6. And we've just been multiplying the 3's. So this is the same as 3 to the power 6. But this way of multiplying everything and listing out everything becomes quite monotonous and quite involving. That's why the rules for solving indices in this case, when you are dealing with the same bases, you simply add the indices. Right, let's look at another basic rule which governs the use of indices. The second one is if we are dividing powers of the same base, then we subtract the indices. So if we are given a to the power m divided by a to the power n, then this means that since the powers, the bases are the same, then we are going to subtract the indices. We can give an example still here to say, given, for example, 4 to the power 5 divided by 4 to the power 3, this means that the first thing here is that the bases are the same, and since the bases are the same, we're going to say the base is 4, we subtract the indices, we are going to say 5 minus 3. This is one of the rules of indices that we can use to evaluate questions on indices involving that. Now let's look at another basic rule, number 3, when we have a raised to power m and then also exponent n. Here we are multiplying, this is the same as a, then m multiplied by n. An example can be given to say, given 2 to the power 3 and exponent 2, power of the power, we are going to say this is the same as 2, then 3 times 2, which gives us 2 to the power 6. 2 to the power 6. So that is also one of the rules that we can use in order for us to work out solutions to questions involving indices of that nature. So we had a to the power m, again multiplied by exponent n, is the same as a to the power m times n. So you don't need to really stress here when you see things happening in that way. The other rule that we can look at is rule number 4. These numbering of the rules can be numbered in a. What's important for you is to know what the rules states and how best you can apply them in solving simple questions on indices. If we have a exponent negative n, this is a negative index, you need to express it as a positive index. So in this case, we are saying a to the power exponent n. In order for us to have this exponent be positive, we are going to say, 1 over a to the power n, and then once we do that, the index becomes positive. Let's quickly look at another one. If we have, for example, a power 1 over n, which is my main interest in this question that we are about to look at, this means that the nth root of a means that the nth root of a. That's what it means. So, for example, if we have 4 and then 1 over 2, this means since the denominator of this index is 2, we are saying this is the square root of 4, which can also be expressed as 4 is the same as, for example, 2 to the power 2, everything multiplied by 1 over 2. Remember the rule that we've just revised up there. And then we are saying this is 2, and 2 times 1 over 2. And then you can see that this and this can eliminate. Then we have 2 to the power 1, and then 2 to the power 1 is the same as 2. So that is what it means here. So if we had, for example, 8 to the power 1 over 3, they are still saying this means the nth root of 8. So here we're saying the cubic root of 8, the cube root of 8, so we're going to say it's the same as writing it either cube root of 8, or you can write it to say 8 is the same as 2 to the power 3, and then you have 1 over 3, which means that here we're saying 2 and 3 times 1 over 3, and this 3 and this 3 will eliminate. So you can see clearly that we're going to have 2. And the cube root of 8 here means what? 2. So wherever you see a power 1 over n, it means they're asking you to find the nth root of the given base or the number that has been mentioned in that question. Right, we can also look at this other, the last one, which we can say a to the power m over n. This means the nth root of a raised to the power m. The nth root of a raised to the power m. So what does this mean? Let me give an example also here. If we have, for example, 8 to the power 2 over 3, this means that we are looking for the cube root of 8. Then that cube root of 8, we raise it to the power 2. And this, we have already seen, ascertained in the first question, the earlier question that we looked at, to say the cube root of 8 is 2. So 2 to the power 2 finally gives us 4. Alternatively, you can work it out like 8 to the power 2 over 3. This 8 can be expressed as 2 to the power 3, then 2 over 3. Then you can see that here we are multiplying, so 3 and 3 here eliminate. Then we remain with 2 to the power 2, and 2 to the power 2 still gives us 4. So those are some of the basic rules of indices that you need to have in mind. You don't need to memorize this is number 1, this is number 2, this is number 3, 4, 5, and 6. You just need to know and understand them so that you can apply them at every point whenever the question requires you to apply the rules of what? Of indices. And so now, going back to the first question, we have been given the first question which we want to look at, but I just wanted you to have a clear picture on how to go about these simple questions that really upsets you when you are in an exam, and then it has got even the ability to really disorient you. You fail even to answer the question effectively because you've forgotten one or two things to do. Right, so the question reads, evaluate. The question reads, evaluate 27 raised power 2 over 3. Evaluate 27 raised to power 2 over 3. So from the basic rules of indices that we've just revised together, this means that it's the same as the cube root of 27, then you raise it to power what? To power 3. The cube root of 27, you raise it to power 2, so not power 3. That is the meaning of this question which we've been asked to find. So instead of going to the cube root of 27, sometimes it may be very difficult for you to look for the cube root of 27. And all what you need to understand is what do we mean by cube root? It's not a calculator version paper, so you just need to express 27 as a product in base 3. So we're going to say 27 here is the same as 3 to the power 3. We have not changed anything. We're just replacing 27 with this 3, multiplying 3 by itself thrice. Then we get 27. Then out there we have 2 to the power 3. And already we have already revised on this rule to say 3 to the power 3 and 23. This means 2 over 3. It means 3, then 3 times 2 over 3. And you can see that you have to be very careful here. This 3 is a base, so it needs to be bigger like that, so that this 3 and that 3 eliminate. So you are going to remain with 3 to the power 2, and 3 to the power 2 is multiplying 3 by itself twice. It's not 3 times 2 as the common mistake which most of the pupils make, but it's 3 multiplied by itself. So you have 3 times 3, which gives you 9. So if we are asked to evaluate that question, the question means evaluate that. That is basically what we need to do in order for us to answer that question properly. Right, so we move on to another question which is still on indices. We wanted to combine this so that you are able to marry the concepts that we have just looked at together. The next question is question 11b, which is also on indices. I think you're able to see question 11b beamed on the screen there, we have tried to put the concepts together so that as we revise a certain topic with the concepts together. So question 11b states, solve the equation 2 and raised to power 2x minus 1 equals 16 raised to power negative 2x. I'm sure you're able to see that question that has been beamed on your screen there. 2 raised to power 2x minus 1 equals 16 raised to power negative 2x. You pose their equation and say, how do I go about answering that question? What should I do? How am I going to go about it, and the like? So, first thing you need to pay a particular attention to is that, are the bases the same? When you look at the bases, are they the same? If they are the same, then you go ahead and equate the powers. So in this question, we have the base for this, the left-hand side. The left-hand side, the base is 2, and the right-hand side, the base is 16. So the bases are not the same. You cannot equate the indices. From the left-hand side, the index we have is 2x minus 1. From the right-hand side, the index we have is negative 2x. So then how do you move in order for you to answer that question? So let's look at the question again. 2 raised to power 2x minus 1 equals 16 minus 2x, 16 raised to power negative 2x. What does this mean? You ask yourself a question. Is it possible to convert this 2, base 2, to have base 16? Or it's possible, it's easier to convert 16 to base 2? And from the look of things here, it's very, very possible to convert 16 in base 2. And once the bases are the same, then it means it becomes very easy for us to equate the powers. So if 16 is expressed in base 2, what is it going to be? Let us try by the first prime number 2. We're saying 2 times 2, that gives us 4. 4 times 2, that gives us 8. And 8 times 2, that gives us 4. The short way of writing 2 times 2 times 2 times 2 is simply 2 raised to the power 4. So 16 can be written as 2 raised to power 4. And having done that, we can replace this value of 16 written in this form in that given question. So what are we saying now? We are going to move on to say 2 raised to power 2x minus 1 is the same, is equal to 2 raised to power 4, and then we put this in bracket. This is 16. We have not changed anything except we have expressed 16 as a product of these prime numbers, and we have used 2, the first prime number. And then we are mindful that there is negative 2x there. So now, what does this mean? This also means that we have 2, then 2x minus 1 equals 2, then 4 multiplied by negative 2x. And now, since the bases are the same, it puts you in a better position for you to work out these this given indices, the given index, or the equation involving indices. So now, what do we do? So we are saying now, since the bases are the same, we shall say 2 and equate. We are going to equate the powers to say, we are going to equate the powers since now the bases are the same. We are going to say, we have 2 here. So we shall say 2x minus 1, this is the power on the left-hand side. And when we multiplied equals, we multiply 4 times negative 2x, we are going to have negative 8x. So for now, what we need to do is to collect the like terms together to one side, and then be able to find the solution or the value of the unknown in this case, which is x. So we are saying 2x, when we transpose this negative x to the other side, I said last time to say it does not cross the equal sign, it does not jump like we are used to saying when it jumps to the other side and the like. So we are just transposing, or we are adding the additive inverse of negative 8x to both sides. What this means here is that we have negative 8x. If we add 8x here, this will remain 0. So what did we add? We added 8x. So even the other side, we should add 8x. That's why we're saying now, if this negative 8x is transposed to the other side, we are going to have 8x. And this negative 1 transposed to the other side, we are going to have a 1 there. Right. So from there now, it's very easy. It's an easy linear equation that you can solve without problems. When you add 2x plus 8x, you have 10x equals 1. And then here we are solving for x, because when they say solve, they are simply asking you to find the value of the unknown. And so the value of unknown in this case, we divide throughout by 10, and then we are going to have x equals 1 over 10. So there you go. You have solved that equation in accordance with the question that has been asked. So you don't need to stress. We have revised 2 questions on indices. The first important thing you need to do is you first get acquainted to the rules, the basic rules of indices, so that you can be able to apply them in solving any questions that can be asked on indices. Thank you so much to Mulongo there. He's already tuned in. Bibiana Gwaba Ichigo also is watching, and Nonom Sumba also there is watching. Thank you so much. Please continue dropping those comments so that you can keep us encouraged in the revision exercise that we are doing together. All right, so away from indices, we want to move on and look at the other question. The other question is question number 6. And question number 6 is on matrices. Question number 6 is on matrices, and these are some of the questions that you need to score a number of marks in the final exam. You don't need to stress at all. So question number 6 is on matrices, and it reads, given that C equals, C is given as 5, negative 1, 2, and 1, and D is given as 1 and negative 2. Mind you, there you don't need to put a division line there to say 1 over negative 2. These are just matrices. Then they are saying express CD as a single matrix. Express CD as a single matrix. How are you going to express CD as a single matrix? Here we are just dealing with the matrix multiplication. So when you're dealing with matrix multiplication, you need to bear in mind that we multiply rows by columns. Rows by columns. That's the rule that you need. In case you have forgotten, what are the rows? The rows are these, and the columns are these. So if the question is asked, what is the order of this matrix C given? The order of matrix C, they're simply asking you, how many rows has it gotten? How many columns has it gotten? So you can see that we have row 1 and row 2. Then we have column 1 and column 2. So the order of this matrix is a 2 by 2 matrix. Then look at matrix D. What is the order of matrix D? Matrix D has 2 rows and 1 column. So it's a 2 by 1 column. So we are going to simply multiply these 2 matrices in order for us to come up with a single matrix. So CD is going to be 5, 2, negative 1 and 1. Then we have 1 and negative 2 like that. So what does that mean? It's a row by column and a row by column. So we are going to say this is going to give us 5 times 1. 5 times 1. I'm sure you're able to see that. 5 times 1. 5 times 1 plus negative 1 times negative 2. 5 times 1, 5 times 1, which is 5, plus negative 1 times negative 2. So negative 1 times negative 2. I'm sure you're able to see that 5 times 1 plus negative 1 times negative 1 times negative 2, okay? Then we have this row, 2 times 1, which is going to give us 2 times 1 plus 1 times negative 2. So now, let's try to clear some space here. So 5 times 1, we're going to have a 5 plus this negative 1 times negative 2, we are going to have a 2. Then we also have 2 plus 1 times negative 2, that is negative 2. Okay, I'm sure you're able to follow that. Then 5 plus 2, that gives us a 7. And 2 plus negative 2, this gives us a 0. So you end up having that. So you don't need to stress there, ladies and boys and girls, as you revise that. We don't need really to spend much time on doing that. So what is our next question now? Our next question is question 11, question 6. We are going to look at, or we have already looked at question 6. We look at question 11, 11A. Question 11A is also on matrices. They are saying the transpose of a matrix P, the transpose of the matrix P has been given as 1, 3, 4, 2, 5, 1, 3, 0, and 1. So the question as it is on the screen here, we have to say P is 1, the transpose of a matrix P is 1, 3, 4, 2, 5, 1, 3, 0, 1. Write down the matrix P. So this is P transpose. And so what do we understand that by the term transpose of a matrix? If we are transposing a matrix, we are changing the rows to become columns, and the columns are becoming rows. So this matrix has already been transposed. Now they want you to find the original matrix before it was what? Before it was transposed. How is the original matrix going to look like before it was transposed? So matrix P is going to be, since the row is 1, 3, 4, so we are going to write 1, 3, 4. Then also we change the row to a column. We come to this row 2. Row 2 has to be changed into a what? Into a column. So we have 2, 5, and 1. And then row 3 also has to be changed from a row into a column. So we have 3, 0, and 1. So this was the original matrix before it was transposed. So if they, in the question, if they say, can you transpose matrix P? Transpose matrix P. So now we are trying to look for P transpose. That's how it is denoted. It's not P to the power T, but we read it as P transpose. So we are going to say 1, 2, 3. This matrix now will be like the way it is. This row, we shall change it to a column. To a column which is 1, 2, and 3. And this other row will be changed to 3, 5, and 0. And this also, the third row, will be changed to 4, 1, and 1. So that is what has taken place in that given question. They were simply asking us to find the original matrix. So they may ask you to transpose a matrix, or simply ask you to find the original matrix once that matrix has been transposed already. So thank you so much to Mwansalombe, who has also joined us, and Protesius is also asking to say, is this program available on the MTN TV Yes, please, you can download an application of MTN TV Plus on your phone, and the program is uploaded an hour after this live streaming, so you can watch even at your own time if you miss the live streaming of this program. So thank you so much to all those that are joining us in this revision exercise that is taking place. Please, we need those comments in order for us to be encouraged and continue revising in that direction. So for now, we are going to pause for a commercial break, I think just for 2 minutes, then we'll be right back for some more revisions. Thank you so much.
I told the bus driver that I work hard for my money, so it better gets to Chipata.
Yeah, that's right. That's what I told him.
Yeah.
Weather, drama no, or Zambili,
Tituma. And he kept trying to tell us something, but I was like, Ukagamba, Tilo.
Cause cash money yeve across Zambia,
Tituma. Ati? At Basi and Kuchpat. The end of South Africa. Hello, what?
Run, K-Stop, run! Don't cut the bus.
Sending money doesn't have to be this dramatic. Open an MTN mobile money account today and send money to friends and loved ones across Zambia instantly. Dial *303# to send money with MTN, Zambia's #1 network. With MTN mobile money, Tituma.
MTN, everywhere you go.
Without music, our lives would be lifeless.
Music gives the mind wings.
Music refreshes the soul on this journey of life and never dies.
It's who we are. I mean, it's what we do.
It's what we feel.
What would we be without music?
The future of music streaming is MTN Music Plus.
MTN, everywhere you go.
Hello! This is all you need to know about data bundles. Like when you need airtime to make calls, you need data bundles to browse the internet, send and receive photos on Facebook, chat on WhatsApp, send emails, listen to music, and many other things. Data is measured in bytes, kilobytes, megabytes, and gigabytes. These are a bit like money, and just like your bank balance, your MTN account has a data balance that you can use to buy data bundles ranging from 5 megabytes to 20 gigabytes for daily, weekly, and monthly subscription. To buy a bundle, dial *335*1#.
From sending emails to browsing or watching online videos, many of the things you use depend on your device's functionality and network capability. Entry-level devices have limited data usage, whereas smartphones and computers have limitless data usage. The longer you spend online, the more data you use.
Sometimes you feel like your data is running out really fast. That's because today's modern technology and higher definition content require and use up a lot more data. No need to worry. Data can be managed to work for you by minimizing on the number of apps that automatically update themselves and turning off your data when not in use. Make sure you use data bundles to browse the internet. When your bundle is depleted, you will be billed from your airtime. Perform regular data balance inquiries by dialing *335*3#.
Rise up this morning, smile with the rising sun. 3 little birds pitch by my doorstep, singing sweet songs, our melodies pure and true, saying, this is my message to you. Singing, don't worry about a thing, 'cause every little thing is gonna be alright. Singing, don't worry about a thing, 'cause every little thing
you use your data is up to you. With the widest network coverage, it's amazing what you can do on MTN.
This is my message to you.
Hello everybody, welcome back to MTN Teleschool. My name is Samanenga. Once more, want to help you prepare for the final exams, which are just around the corner, and we want you to pass mathematics with flying colors. And so please remember to tag your friends and families so that they can be able to join us and also be able to help themselves in the revision exercise. Thank you so much to Ruthie Mlanga, who has also tuned into this program. Lumamba Benzu is also appreciating that. These very nice lessons and a very good program. We also have Tabitha Mwila. They are also tuned to this MTN Teleschool, and they are very excited and happy about the revision exercise that is taking place. Please remember, as I have said earlier on, that you tag your friends, you tag your families. If you can sit together and watch together and also discuss about this question, drop a comment for us so that we can be encouraged to go ahead with the same spirit which we are doing. Also remember that this program can be viewed in case you leave you miss the live streaming. You can upload, you can download on your phone MTN TV Plus, and you'll be able to watch these videos of the lessons an hour after the live streaming. Everything is just there, and in your comfort zone, you'll be able to do what your friends have done if at all you missed it, or if at all you're still in class, or you're still in school, or you're busy doing one or two things. Right, so now we want to continue. We're going to look at another question, which is question 20A, and question 20A reads, as it can be seen on your screen: find the equation of a line which is parallel to 2x plus y equals 3. And this equation, which is parallel to this equation, passes through the point -2 and also 3. -2 and 3. Right. Now, where is this question? Which topic is this question coming from? This question is on coordinate geometry. This question is on coordinate geometry, and under coordinate geometry, there are a number of small building concepts that you need to bear in mind as you prepare for this program, as you prepare for your answering of this question. So what you need to get in mind, you need to know how to calculate the gradient. And gradient is simply the slope of a straight line. So when you see in some books they have written, what is a slope of a straight line? They are simply asking you about the gradient of a straight line. Simply slope, the other word they use is what? Is gradient. Okay, you also need to know that when lines are parallel, it means they do not meet, they can be in this way. So this line, if this is line AB and this is line BC, they are parallel. But the way I've drawn them, their gradient is 0 because there isn't any slope of any kind. So let me draw them like this. For example, if this is line A and this is line B and line C and line D, these lines are parallel, meaning they are not meeting at any point. Then it means their gradient are what? The gradient of the two lines is the same. That is what you need to put in mind. But there's also another concept that I want to introduce you to about perpendicular lines. What are perpendicular lines and what do you understand them? So we have ascertained that parallel lines are simply lines that do not meet at any point. So these two lines, for example, AB and CD that I've drawn here, can also be written in one line like this. So we have A, B, and C, and D. They are lying on the same straight line. We can simply join them together and say these are two lines which are still parallel. So they can be written also in that form. But in order for us to see them clearly, we can label them like that. But before I answer the question which has been asked, I also want to talk much about the same concepts that you need to know about the same gradient. Given the XY plane or the Cartesian plane, for example, if you have, this is the Cartesian plane, which is the y-axis and the origin, the point of intersection, and the x-axis. A line that slants from top right to bottom left has a positive gradient. You need to know that. So a line that slants from, oh, sorry about that. We have our x or y plane, which is the Cartesian plane. So I'm saying the line that slants from top right to bottom left has a positive gradient. So if it passes through this line, for example, if this line is AB, its gradient is going to be positive after calculation. Another line can be parallel to this. Even this line will have a positive gradient. But as long as these two lines are parallel, then we can ascertain that they have the same gradient. But if the lines are slanting from top left to bottom right, top left to bottom right, let's say C and D, they're slanting from top left to bottom right, this line has a negative gradient. And even if we have another one, CD, and then we say this is E and F, these two lines will still have the same gradient. But we can also have this situation where this is our Cartesian plane, X and OY, X, OY. Then you have a line like this. This line is not slanting, so it has got zero gradient. So you need to understand those small points about coordinate geometry. Now, we also know that a line that passes through the origin as a basic line, that passes through the origin and slants from top right to bottom left, but it passes through the origin. This line is called y equals x, I'm sure you know. And the line that passes through the origin slanting from top right, top left to bottom right has a negative gradient, and we call this line as y equals negative x. So you need to know those basic graphs, and then you'll be able to understand clearly what is supposed to be done. Now I want to answer the question that has been given after giving a background about, simple background about coordinate geometry, and we need now to really answer any question that is being asked concerning coordinate geometry. Right. I said earlier on that under coordinate geometry, you are expected to know or to understand how to simplify the equation of a straight line. You're supposed to understand how to find the midpoint. You're supposed to understand how to find the distance between 2 points and the like. I remember in the previous lesson that we had last time, we looked at how to calculate for the distance and the gradient. Now, if you have 2 points, for example, 2 and 4, and then we have another point, this is point A, and just for the sake of those that missed the first lesson, if you have another point A and then another point B, and then they ask you to find, this is 3 and then this is 5, they say, can you find the gradient of a line passing through the points 2 and 4 and 3 and 5? Great. So what do? We know that gradient is given by m equals the change in the y coordinates divided by the change in the x coordinates. You don't need to miss that. But sometimes I don't encourage pupils to simply memorizing the formulas, because there are so many formulas that you need to memorize before you write your final exam. What is important, you need to understand what to do. If I've been given 2 points, how am I going to find the gradient of a straight line? So we are saying gradient of a straight line is equal to y2 minus y1, everything over x2 minus x1. So we have been given 2 points there. The first entry of the point in A is x1, we can name it x1. Then this is y1, don't name it y2, x2. Then this is x2, and this is y1. Just for the sake of those that missed the first lesson that we had last time. So we are saying now, what is the gradient of these 2 points? So what is my y2? See here we made a mistake. This is y2. My y2 is 5 minus y1 is 4. Then everything over, what is x2? We have our x2 as 3 minus our x1 as 2. So from there, you have 5 minus 4, that gives you 1. And 3 minus 2 also gives you 1. And 1 divided by 1, we have 1. So the gradient of the line passing through AB in the points 2, 4 and 3, 5 is simply 1. Ask yourself, is it a positive gradient or negative gradient? You can see that it is positive, and since it's positive, if we are to draw that line on the x or y plane, we are going to see a line that is slanting from top right to bottom left. But how else can we find the gradient of a straight line? We need also to understand that the equation of a straight line is written in the form y equals mx plus c, where m is the gradient and c is the y-intercept. So y-intercept c is representing a point at which that straight line is cutting the y-axis. So for example, if you have an equation y equals 2x plus 1, then they ask you to say, can you find the gradient of this? When you look at the standard form of the equation of a straight line, this 2 is representing the gradient. So from this equation, the gradient is simply 2, and the y-intercept is simply y-intercept is simply 1. So if we are to draw this equation on the x or y plane, we have y equals 2x plus 1. We can come up with a solution box where 2 points are enough. This is our x, this is our y, and this is our 0, this is our 1. Y is 0 and 1, we can pick any arbitrary number, and then you'll be able to replace it in the equation. If x is 0, what will be y? Replace here. We will have 2 and 0, then plus 1, and then 2 times 0, you have 0 plus 1, so it means y will be 1. If x is 1, what will be your y? So again, you do the same. You say y equals 2, then 1 plus 1, and then 2 times 1 is 2, and then 2 plus 1, and that gives you 3. So if x is 1, then your y is going to be 3. You can plot that on your Cartesian plane, and this is your y-axis, this is your x-axis, and this is your origin. So we have points. We want to plot the points. Let me write them here. 0 and 1, and want to plot another point 1 and 3. Okay, so we have 1, 2, 3. Let's say 1, 2, 3, 4 also. 1, 2, 3, and 4. Then 1, 2, and 3. So 0 and 1 is this point, and 1 and 3 is going to be, if we go a straight line there, so we are going to have a line that is passing through that point. So it's a straight line. If you use a ruler to draw that line, so this is the line of y equals 2x plus 1. With that explanation and the background I've given, now it puts you in a better position for you to answer the question that has been given confidently without fear or favor. So what have we been asked to do? What have we been asked to do? The question states, as it is beamed on your screen, find the equation of a line. Find the equation of a line. Just a minute so that we can create some space for our working. Find the equation of the line which is parallel. This line which is parallel to 2x plus y equals 3. And this line passes through the points -2 and 3. So they are asking you to find the equation of a line which is parallel to this given equation. Now, we need to ascertain something like that, what I said earlier, to say parallel lines have the same gradient. And when you look at the equation given, it is an equation of a linear equation, and it's an equation of a linear function. If it's drawn on the x or y plane, it is going to give us a straight line. So first of all, you need to remember that the standard form of a linear equation is written in the form y equals mx plus c. Y equals mx plus c. Now, when you look at the equation that has been given, rearrange it in that order. Rearrange it in the order of the standard form of the equation of a linear or a straight line. So we are going to make y the subject. So we shall say y equals, then this 2x is transposed to the other side. So when it is transposed to the other side, it's going to be negative 2x plus 3. Now you have arranged this equation in the standard form of an equation of a straight line. So first of all, you need to know the gradient. What is the gradient of this equation? M here represents the gradient, and C represents the y-intercept. The y-intercept, as I said earlier, is simply a point at which this graph is cutting the y-axis. So now, what is the gradient? The gradient is negative 2, according to that given equation. But we have ascertained that the gradient of a straight line is the same. The gradient of two parallel lines is the same. So now, the question is telling us to say, find the equation of a line which is parallel to 2x plus y equals 3. So we start having in mind, how is this equation going to look like? Okay, so we have now the gradient which is negative 2, and we have this equation which is parallel to the earlier equation given is negative, it's passing through the point negative 2 and 3. So we know that gradient is gradient m equals y2 minus y1 everything over x2 minus x1. You see that? So, but we've already ascertained what is our m, or the gradient. The gradient is negative 2. But we also have 2 points here, which is x here, and which is x and also y. So we are going to use these 2 points to find the equation of a straight line by saying y minus 1, the y value which is here, in this case is 3, everything over x minus the x value there, negative 2. It should give us the gradient which we have found of negative 2. That is the simplest way we can go about this. Now, you have to pay attention with the signs and the operation there so that you don't disturb yourself or lose marks on this good question. So now you are expanding there to say first the numerator will have y minus 3, everything over x, negative times negative gives us positive, so you have 2 equals negative 2. Right, so all you need to do now here is to simply cross multiply, and when you cross multiply this and this, you are going to have 1, then y minus 3, just for the sake of those that cannot follow. Then we have negative 2 here and x plus 2. Right, and then from here we have, if we expand this, we are going to have y minus 3 equals negative 2 times x. We are going to have negative 2x, but please be careful here. Don't rush into bringing this operation down, because this negative 2 is being distributed to what is in the brackets. So you don't make that mistake. You will end up making a very terrible mistake that is going to cost you marks in an exam. So you say negative 2 times positive 2 or plus 2 here, you are going to have negative 4. Right. So that is what you have now. You have y minus 3 equals negative 2x minus 4. Now you need to rearrange this. Equation so that it suits the standard form of a linear equation. That's what you need to do. So what are we saying now here? We are going to collect the like terms. We are going to say y equals negative 2x minus 4. then this -3 is transposed to the other side. So we are going to have -2x minus 4 plus 3. And then we are going to have y equals -2x minus -4 plus 3 is going to give you -1. So this is the equation which is parallel to the given equation. Now, let us compare the two equations. The first equation given was 2x plus y equals 3. And the equation that is parallel to this equation is y equals -2x minus 1. So now when you look at the two equations, you'll be able to see that we have ascertained that parallel lines have equal gradients. I want you to see it clearly as it comes out, so that even when you're talking about parallel lines with your friends, you understand exactly what we are talking about. So when we rearranged this in standard form, this equation rearranged, we had y equals, we transposed this to the other side, so we have -2x plus 3. So this equation is not different from this equation. There is one and the same, except we've just rearranged them. Then the other one is y equals -2x minus 1. So these two equations are parallel. The first one is cutting the y-axis at 3. The other one is cutting the y-axis at -1. But we have ascertained that parallel lines have equal gradients. What is the gradient of this line? Let's get back to the basic standard form of writing an equation of a straight line. So we write it as y equals mx plus c. We can also do the same this side, y equals mx plus c. So this m represents the gradient. This m represents the gradient. So what is the gradient in this case? It is -2. And what is the gradient in that case? It's also -2. So that satisfies our working to say parallel lines have equal gradients. Hangoma, thank you so much for the comment, and Kuya Vevela, you're also encouraging us to say you are following us and you're tuned in. Solomon Njovu is also very grateful that he's following us on this MTN Teleschool live streaming. So basically, that is what you are expected to do in this question. So we want to move on and look at another question before we close the session this hour and look at something else. So please remember to tag your friends and families so that they may be able also to join us and revise with us. Please, like we have always been saying, we have come here to solve, to help one another, to help you prepare for your final exams. You don't need to be nervous. You don't need to be nervous. There's no need of being nervous at all. You just need to be yourself, build the confidence, go and sit on a desk, get the question paper. Just give your best shot, because MTN Teleschool plus the good teachers who are also out there in schools are doing everything possible to ensure that you are fully prepared for the final exam. Right, so now we move on. We go to our next question, and our next question is question 19. And question 19 reads, integrate 3x to the power 4 minus 4x power -3 with respect to x. This is an addition topic that has been included in the revised curriculum. And a number of pupils, whenever they hear calculus, what is this calculus? They become defeated and they do not just want to have anything to do with calculus. The reason why I want you to first get acquainted with some basic calculus, because when you go out there to further your studies in the university and colleges of your choices, engineering and all that, the mother of mathematics is calculus. You apply it in physics, you apply it in mathematics, in engineering, and all that stuff that you need. So we are here to give you the basic just calculus to help you cope with the pressure of being the first year at the university, the first year at your college of your choice, and the like. Integration. Last time I talked about integration as a reverse of differentiation, so I'm not going to take much time on this question to explain much more, but I'm sure there's another question that is coming in paper 2 where I'm going to spend much time so that you can really understand what we are talking about. We need to integrate this. What do we need to know? When we are integrating, what else do we need to know? Under integration, we are saying the power increases and the new power, the base is divided by the new power. So we have two terms in this case. We have two terms, 3x to the power 4 minus, and we also have negative 4x to the power negative 3. Those are the two terms that we have. So the power we shall increase here, and also the power shall increase there by 1. And when the power increases, we are going to have 3x. Let me write it here. We are going to have 3x power 5, but then the base, this 3, should be divided by the new power, which is 5, then minus 4x, negative 3 plus 1 gives us negative 2, so the new power is negative 2 here also. We have negative 2, right? I hope you're able to follow that. And now we can really just evaluate, or maybe before we even go any further, we can express this as a positive index like I said earlier. We have 3x, let me write it here so that you're able to follow nicely. The question is 3x to the power 4 minus 4x to the power negative 3. So already we have ascertained that this is a negative index. So since it's a negative index, we can express it as a positive index, and this is going to give us 1 over 4x to the power 3. So there's nothing wrong in saying 3x to the power 4 minus 1 over 4 and x to the power 3. It's one and the same thing. So you really don't need to struggle a lot. But maybe it might be very difficult for you to see how the powers are increasing and the rules that we are applying. That's why I said earlier on, if we have 3x to the power 4 minus 4 and x to the power negative 3, the power is increasing by 1. That is the concept behind. So when the power increases by 1, then we are supposed to divide the base by the new power. So we have 4 plus 1, which is 5. So we're saying we're going to have 3x to the power 5 over 5, then minus 4, and the x, negative 3 plus 1, we have negative 2. So also we're going to have divided by negative 2. So what are we going to have now there? That is what you need to, we're saying we are integrating with respect to what? To x. So you simply now have this in mind. You have made the powers, be like that. And so you simply now need to say, okay, fine, this is going to be 3 over 5x to the power 5. Then we have this negative, and which can change this to plus 2, then x to the power negative 2. That is it. You don't need even to struggle a lot. It's a 2-mark question, and then you move on in that direction. Right, I said you don't need to stress much because we have another question in paper 2 that is coming, so that you can really be able to understand much on some basic calculus, differentiation, and also integration in that aspect. We're now going to look at our last question for this session, and this question is on equations. A simple equation also that needs you to get really some marks for you. Thank you so much to Ben Muso, who is also following us. Pule also is saying that is very great. Solomon Njovu said that's very true. And we are encouraged by following and the comments that you are dropping. As I've always been saying, tag your friends and your families. They don't need to miss this opportunity. MTN Teleschool is here to ensure that you are fully prepared for your final exam. Right, the question states solve 2x minus 1 all squared equals 25. 2x minus 1 all squared equals 25. When you look at this question, the fact that the highest power to which the equation has been raised to is 2 means that it's a quadratic equation. And I earlier on said quadratic equations can be solved in so many ways. We can solve quadratic equations by factorization. We can solve quadratic equations by complete of square method. We can solve quadratic equation using the formula and many other methods that you can come up with to solve the quadratic equation. But the number of marks given in an exam will tell you the formula that you may use in order for you to solve that equation. If the number of marks was given as 5, you can either use complete of square method or the famous quadratic formula to solve the equation that you have you've been given. Right. Now in this question, the number of marks given is too little and this is just 2. So what are you going to do? Are you going to expand this? Because that is what most of the pupils or students out there want to do. They want first to expand this, and when they expand, they equate to 25, collect 25, then 0. Then they have the complex quadratic equation that they need to solve now, either by complete of square method or simply by a quadratic formula. In this case, you don't need even to stress. You don't even need to be shaken. It's very simple because the power to which this expression on the left-hand side is raised to is 2. And when you look at this number here, 25, 25 is a perfect square, meaning its square root can easily be found. And the square root of 25 is simply 5. And this means that it puts us in a better position for us just to say, okay, this is the question that I have. 2x minus 1 raised to power 2 equals 25. I'm going to get rid of this 2 by introducing the square root sign to both sides. Whatever I do this side should be done to the right-hand side and the left-hand side. So once I introduce the square root sign, it means this 2 and this radical, the square root sign, will eliminate itself. Then we're going to have 2x minus 1 remaining equals square root of 25, the positive square root is 5. You have a very simple linear equation that you need to solve there. So we are going to say 2x, when you transpose this side, you have 5 plus 1. And then you have 2x, equals 6. Then 2x, when you divide throughout by 2, because we are solving for the unknown and our x is going to be 3. Is it true that when the value of x is 3, I'm going to have a balanced equation? Remember, if I substitute this 3 into the given equation, for example, if I substitute this 3 here, am I going to get 5? So we have 2x minus 1 equals 5. We have ascertained that the x is 3, so we say 2 and 3 minus 1 is equal to 5. So 2 times 3, we have 6 minus 1, that gives us 5. And 6 minus 1, 5 is equal to 5. So there you go. You don't have to stress. So I want to stress if at all we have 2x minus 1, for example, raised to power 3 equals 8, for example, then they ask you to solve. It's the same thing that you need to do. You need to understand that to get rid of this power 3, I need to introduce the cube root sign, which is going to be introduced to both sides. So if it was a 3 there, I'm going to say cube root of 3, then 2x minus 1 power 3, so that this and this will eliminate, equals 8. Whatever I do that side, I'm also going to find the cube root there. So we are going to have a situation where we have 2x minus 1 equals the cube root of 8. Remember, it's multiplying which number when multiplied by itself 3 times, it gives us 8. The cube root of 8 is 2. And then you can smile to say 2x equals 2. Transpose this to this side. You have plus 1. Then you have 2x equals 2 plus 1, which is 3, divided by 2 by 2. And your answer x equals to be 3 over 2. Or you say x equals 1 and 1 over 2. That's it. Thank you so much for joining us once more. This is MTN Teleschool, and we are really here to help you revise mathematics. This has been my first session, and my name is Samanenga. I've been with you from 14 hours to 15 hours now. We are going to have a break for an hour so that those that have missed this live streaming can be able to view it on MTN TV Plus, so that you can view it at your own time. Thank you so much, Solomon Jovu, for staying tuned. Ben Muso also, we are so grateful. So for now, I said, please don't go away. I'll be back in an hour's time to look at a few questions here and there as we prepare for your final exam. So please stay tuned, and bye-bye for now.
I told the bus driver that I work hard for my money, so it better gets to Chipata.
Yeah, that's right. That's what I told him.
Yeah.
Whether drama is ngono or nizambili
Tituma. And he kept trying to tell us something, but I was like, Ukagamba, Tilo.
Cause cash money yeve across Zambia.
Tituma. At basi and Kuchipata. The end of South Africa. Hello, wait!
Run, K-Star, run! Don't cut the bus.
Sending money doesn't have to be this dramatic. Open an MTN mobile money account today and send money to friends and loved ones across Zambia instantly. Dial *303# to send money with MTN, Zambia's #1 network. With MTN mobile money, Tituma.
MTN, everywhere you go.
Tiende pamoja ni mtima umo. 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 Tiende pamoja ni mtima